All right, so we're going to start chapter 1, section 2, part A, solving linear equations in one variable. A lot of this is very familiar from Algebra 1. It's going to start super slow, right? But as it progresses, we'll get into some more difficult examples. All right, but in the beginning, it's going to be nice and easy. All right, so in general, right, and again, you maybe remember this from Algebra 1, right? Ever since then, you couldn't really avoid it. Even in geometry, you had to do solving some equations, right? So what we're doing here, we're isolating the variable. Now there's going to be some special cases, which we'll get to towards the end, where the left and right side of the equation are equal, and this is going to give you an all real numbers solution. And if the variables cancel out, if what's left is a false statement, then we get no solution. But we'll get into some more examples towards the end that involve these cases. All right. All right, so let's get started with these first few examples. All right, like I said, these are going to be very slow, right? So these are things that you may be able to do already, right? Because you've had to do them since Algebra 1. You may be seeing this from middle school, all right? But again, we're going to start really easy and then it's going to get a little more difficult. All right, so looking at number 1, if I have 3x minus 6 equals 0, right, the goal here is to get the x by itself, right? So we're going to do 3x minus 6 equals 0 to undo this equation and get the x by itself. We're going to do the inverse operations, right? So opposite of minus 6 is going to be plus 6, right? We're undoing this equation, so we're doing any addition and subtraction first, right? So 3x equals 0 plus 6 is 6. All right, and then now that we took care of any addition and subtraction, we're going to do multiplication and division next, right? So this 3x is the same as 3 times x. So we're going to divide both sides by 3. All right, very basic, very simple. All right, so we get x equals 2, right? 6 divided by 3 is 2. All right. And then let's try number 4 next, right? So I'll go left to right, right? So even though they're not in numerical order, right, I'll still do it from left to right. It shouldn't be any more difficult, right? So again, when you're looking at something like number 4, right, 7x plus 2 equals 23, we want to undo this equation to get the x by itself. All right, so we want to subtract 2 on both sides. Let's start there. And then 2 minus 2 gets you 0, so then we get 7x equals 23 minus 2 is 21. All right, and then you want to divide both sides by 7. All right, this 7x is the same as 7 times x. Opposite of multiplying by 7, dividing by 7. And then we cross out our x's, and then we're left with, or we cross out our 7's, and we're left with 21 divided by 7 is 3. All right, and then the next few examples are going to be very similar, right? So 5x plus 4 equals 3x minus 8. Again, we want to get the x's on one side and we want the constants on the other, right? So I like to get the x's on the left-hand side of the equation, right? So we can start by moving this 3x, right? So let's subtract 3x on both sides. All right, and when you subtract 3x from 3x, you get 0. So then we're left with 5x minus 3x is 2x. Plus 4 equals negative 8. All right, and then from here, we can get our constants to one side of the equation, right? So we have a plus 4 on the left-hand side. To get rid of that, we want to subtract 4. All right, 4 minus 4 gets you 0. And then we're left with 2x equals negative 8 minus 4 is negative 12. All right, and then the last thing you want to do, divide by 2. All right, so then you get x equals negative 12 divided by 2 should get you negative 6. All right, and then your answer is negative 6. X equals negative 6. All right, and let's keep going. All right, same thing here for number 5. All right, I want the x's on one side, the constants on the other. All right, again, I like the x's on the left-hand side of the equation, so we can start by adding 2x on both sides. All right, and then negative 2x plus 2x cancels. right? 5x plus 2x is 7x. And then just bring everything else down. All right, and then we can subtract 3 on both sides. All right, and then 3 minus 3 is 0. So then we're left with 7x equals 6 minus 3 is 3. And then the last thing we want to do is divide both sides by 7. So then we get x equals 3 over 7. Right, and this is an acceptable answer. I know you guys like the whole numbers, the integers, right? But sometimes we will get solutions that are rational numbers, right? So don't let that scare you, right? You want the x by itself, right? I saw it in class, maybe some of you stopped right here, right? We don't want to do that. We want the x by itself, right? So got to get rid of that 7 in front of it by dividing, right? And we're left with a fraction as an answer, but again, that's perfectly fine. All right. All right, let's keep this going with number 3. All right, so we're going to do the same steps as always, right? We want the x on one side, the constants on the other, right? So we can move this 7 in front of this negative x, right? So let's subtract 7 on both sides, right? Opposite of a positive 7 is a negative 7, right? So 7 minus 7 is going to get us that 0, right? And then we're left with negative x equals 19 minus 7 is positive 12, all right? And then the last thing we want to do, right, our answer is not done. Even though you don't see a coefficient in front of that x, you think you're done? No, right? We have to divide this by negative 1 to get rid of that negative. Divide or multiply by negative 1. Either way, you'll get the same answer, right? But when we divide by this negative 1, right, negative x becomes positive x. So then we get x equals 12 divided by negative 1 is negative 12. All right, so that's an important step. Don't forget to divide by that negative 1. Right, we want a positive x. All right. All right, so similar case with number 6. Right, so we'll go through the steps as always, right? 7 minus 2x, we want to get rid of that 7 in front of that minus 2x. All right, so let's start there. Minus 7, and then 7 minus 7 is 0. We're left with negative 2x equals 15 minus 7 should get you 8. All right, and the last thing you want to do is divide both sides by negative 2. All right, it's not just going to be 2. We want to get rid of that negative in front also. All right, so we're going to do negative 2x divided by negative 2 is going to cancel out. And then we're left with x equals 8 divided by negative 2 is negative 4. Right, so the negative makes all the difference, right? So if on a test or a quiz you just write positive 4, right, it's more than just a little mistake, right? These are completely different answers if you were to write x equals 4. Right, completely different answer. Your answer is not going to be 4, it's going to be negative 4. Right, so don't make the little mistakes of little sign mistakes, right? So positive divided by negative is always going to get you a negative. You need to be on top of that, all right? All right, so let's keep going with some examples. All right, so something like number 7. Again, we want the x's on one side, we want the constants on the other, right? So I always like to move the x's to the left, right, like I said before. So I'm going to subtract 5x on both sides. All right, and I think a lot of you in the same step are going to move the negative 9 to the other side, right? So I'm going to do that too. Right, because then what cancels, right? Well, on the right, 5x minus 5x is going to go away. And on the left, minus 9 plus 9 is going to go away. All right, so then we're left with 7x minus 5x is going to get you 2x. And then 7 plus 9 is going to get you 16. All right, and the last thing you want to do is divide by 2. All right, divide both sides by 2, we get x equals 16 divided by 2 is 8. All right, nothing new there. All right, and number 8, okay, we have something a little bit new, but something you should still be able to do, right? So we're going to start by distributing, right, this 6 to each term on the inside of the parentheses. Same thing with this 3. We're going to distribute it to each term inside the parentheses. All right, and that should give you with an equation that looks like 6x minus 6 plus 4. right? So this came from distributing the 6, and then that plus 4 is still on the outside, right? So, and then we distribute the 3. 3 times 7x is going to get you 21x, all right? And then 3 times 1 is 3. All right, and now you want to combine like terms. Right, so we're going to do negative 6 plus 4 is going to get you negative 2, and then bring everything else down with it, right? So 6x minus 2 equals 21x plus 3. All right. And now let's move the constants to one side of the equation. The x is on the other, right? So I'm going to go ahead and add the 2 on both sides, and then subtract the 21x on both sides. All right, and on the right, 3 plus 2 is 5. And on the left, 6x minus 21x is going to get you a negative 15x. All right, and then we just want to divide both sides by negative 15. All right, again, don't forget the negative. All right, and then negative 15 and negative 15 cancel out. So we get x equals 5 divided by negative 15. All right, find a common factor, cross it out, we're going to get negative 1/3. All right, 5 goes into both 5 and 15. All right, just cross out the common factor, we get negative 1/3. All right. And then same thing with number 9, right? We just want to distribute the 4, and we want to distribute the 5x, or just the 5. And then this should give us an expression or an equation that we're familiar with, right? Distributing this 4 is going to give us 4x plus 8 minus 12. And then distributing the 5 is going to get us 5x minus 30. All right, again, combine like terms. 8 minus 12 is negative 4. Bring down the 4x equals 5x minus 30. And then get the x's to one side of the equation and the constants on the other. All right, so let's subtract 5x on both sides. All right, those cross out, and we can add 4 on both sides as well. All right, and then 4x minus 5x is negative x. And then negative 30 plus 4 is negative 26. All right, again, you don't want to leave your answer like this. You want to get rid of that negative. All right, so we're going to divide both sides by negative 1, and then we get x equals 26, positive. All right, so let's continue with some examples. All right, so these are going to be very similar to the last ones that we did. So we want to distribute this 3 to each term. And then what are we going to do about this negative? All right, so if you remember, the negative just makes every term on the inside of the parentheses its opposite sign. So in other words, you can think of it like a negative 1. And then you're distributing a negative 1 to everything. All right, so we get 3 times 2x minus 4 is going to get us a 6x minus 12 equals 7. And then the negative, again, changes the sign of everything on the inside of the parentheses. So minus x minus 5. All right, and this becomes a standard problem that we've done a couple times before. 7 minus 5, combine like terms, you get 2 minus x. And then we get 6x minus 12 equals 2 minus x. All right, so let's get our variables on one side, constants on the other. So let's add the x on both sides, and then let's add the 12 on both sides. All right, so then 6x plus x is going to get us a 7x, and then 2 plus 12 is going to get us 14. And then we want to divide both sides by 7, and then finally we get 2 as our answer. All right, same thing here. All right, we want to distribute this 4 and then distribute this negative. Again, we can think of this negative like a negative 1. All right, and then distribute negative 1 to each term. Or you could just know that the minus changes the sign of everything on the inside. All right, so 4 times negative 2x plus 1 is going to get us negative 8x plus 4. And then we get that 6, and then the negative, again, changes the sign of everything on the inside. We get minus 2x plus 4. All All right, so we can combine like terms. 6 plus 4 is going to get us 10 minus 2x equals negative 8x plus 4. All right, and then we can move the x's to one side, the constants on the other, so we can add 2x on both sides. And then we can subtract 4 on both sides. All right, and then negative 8x plus 2x is going to get us a negative 6x. And then 10 minus 4 is going to get us a 6. All right, lastly, we want to divide both sides by negative 6. All right, so then x equals 6 divided by negative 6 is negative 1. Again, do not forget the negative. All right. All right, and now something like number 12, we did this in class. I kind of took the long way to do it, right? Just to kind of show you guys that's not the way that you're going to want to do it every single time, right? So with this one, you guys learned a better way to do it, and it's to multiply by the least common multiple or the least common divisor or least common denominator. All right, so let's look at our denominators here. We have a 5 and a 3, right? So something like these, 5 and 3, we want to think, what can we multiply this entire equation by to get rid of the 5 in the denominator and to get rid of the 3 in the denominator? Right, so to do that, we need a least common multiple. Now between 5 and 3, right, it's going to be 15, right? And if you don't know how I got the 15, right, if you need to write it out, if you remember from elementary school, right, so 3, multiples of 3 are going to be 3, 6, 9, 12, 15, and 15 is a multiple of 5 as well, right? So 5, we're going to have 5, 10, 15, 20, and so on, but they share a 15. All right, so let's go ahead and do that. Let's multiply both sides by... All right, let me erase that. Let's multiply both sides by the least common multiple. All right, so let's multiply this side by 15, and let's multiply this side by 15 as well. All right, so when we do that, 15 divided by 5, that's just going to get us a 3. Right, so we can cross those out and replace it with a 3. All right, same thing here. 15 divided by 3, right? We can cancel those out and replace it with a 5, right? 15 divided by 3 is 5. So then this equals 5 times x plus 2. And now we got rid of the fraction, and this becomes an easy problem, right? We just want to distribute the 3 to everything. So then we get 6x plus 15. And then we want to distribute the 5 to everything. So then we get 5x plus 10. All right, and then now, as always, get the x's to one side. Get the constants on the other. All right, so 15 goes away, 5x goes away. Then we get 6x minus 5x is just x. And this equals 10 minus 15 is negative 5. All right, so again, I showed you guys a different way to do it in class, right? I think I distributed this 1/5, right? And we got a bunch of fractions, and then we needed to find a common denominator, right? And then combine the fractions, and then multiply by the reciprocal. Right? We went through a whole bunch of steps, right? But I just wanted to show you guys there's a better way to do it, right? And this is the way that's actually going to be most beneficial to you guys. Because in the next section, we're going to deal with rational expressions the entire way through. Rational equations, I should say. Right? And so we want to find a way in all of these kinds of problems to get rid of the fraction right away. Right? That's going to make these problems super easy. Right? And that's always the hardest part too, is to find the common denominator, find the common multiple that's going to get rid of that fraction altogether. But once you do that, this problem became super easy. All right. All right, so let's do the same thing for number 13. All right, so let's keep doing these kinds of problems. All right, so something like number 13, we see a whole bunch of fractions, right? And so like I said, in the previous example, the easiest way to do it is to find a least common denominator or least common multiple, right? To get rid of the fractions altogether, right? So here, between 3, 2, 4, and 3, right? So between these four numbers, right, and 3 is a repeat, right? So between 3, 2, and 4, right, what is the least common multiple or the least common denominator? Right, so between these numbers, right, it's going to be 12, right? 3, 6, 9, 12, 2, 4, 6, 8, 12, or 10, 12, and then 4, 8, 12, right? All these are multiples of these numbers, and 12 is the smallest one that they share in common. All right, so with this problem, right, let me erase these. Okay, yeah, let me just get rid of that, right, just to make this problem a little bit easier to do. Okay, so I'm going to multiply this entire equation by 12. All right, so then what I'm going to do is distribute 12 to every single term, right? And so writing all this out, right, I'm just going to write out every step. Maybe you know already what's going to cancel out, all right, so I'm just going to write every step anyway, in case you don't see it right away. Right, so here we get 12 times 2x plus 4 over 3. All right, in our next term, we get 1/2 x times 12, right? 12 times 1 is 12. We can leave the 2 on the bottom, x. All right, and then 1/4 x times 12, right? We can do the 12 times the 1 is going to be 12 over 4x, and then minus 7 times 12 over 3. All right. And now the whole point of doing this is because we have now an opportunity to cancel out all of the fractions. All right, so let's look at this first term. 12 and 3, you're able to cancel those out. All right, so this is going to be, once you cancel these out, 12 and 3, you can cancel them out and you can replace it with a 4. All right. 12 and 2 go away. These become 6, right? 12 divided by 2 is 6. 12 divided by 4, that's just going to give you 3. And then 7 times 12 divided by 3, I'm just going to do 12 divided by 3 is going to give you 4. So replace it with the 4. You could have also done 7 times 12, 84. 84 divided by 3 and did it that way. Right, but I just wanted to make it a little bit easier. Right, I think this is a little bit easier to compute than 84 divided by 3. All right, so now that we have this, all of our denominators are gone, right? Canceled all of them out, right? And so what are we left with now? Right, I'm going to write it up here. All right, we're left with 4 times 2x plus 4 plus 6x equals 3x minus 7 times 4 is 28. Right, and now we got rid of all of our fractions. Right, and now we can just solve as normal. Right, distribute the 4 to everything. Then we get 8x plus 16 plus 6x equals 3x minus 28. All right, combine like terms, 8x and 6x give you 14x plus 16 equals 3x minus 28. All right, and then just move all the x's to one side. All right, so move the 3x over, and then the constants to the other. All right, so minus 16 minus 16. All right, so we should get 14x minus 3x is 11x equals negative 28 minus 16 is negative 44. And now all we have to do is just divide both sides by 11. And then negative 44 divided by 11 is negative 4. All right. So again, it looked really complicated in the beginning because we had all these fractions, right? But if you recognize that you need to multiply by the least common multiple of the denominator, then it gets rid of the fractions altogether, right? So that just made this problem a problem that we've been solving for the past couple problems, right? Just get rid of the fraction altogether, it'll make this problem super easy, right? But that's always going to be the hardest step, and I even saw in class some of you were struggling a little bit with this concept, right? You have to know what to multiply this entire equation by, right? Because that's just going to make it super easy, right? You don't want to deal with fractions the entire way through. That's just going to make it super complicated, all right? And we'll do the same thing with the next one, number 14, right, for extra practice. All right, so 14, we have 2 over 3x plus 0.25x equals x plus 2. Right, so let's stick to fractions, right? We see a mix of fractions and decimals in this one. What is 0.25 the same as saying? Right, do we know that? Right, so this is the same as 1/4, right? 1/4. All right, so let me just rewrite it all together. All right, 2/3 x plus 0.25 is the same as 1/4 x equals x plus 2. And then we can solve this the same way that we solved the last problem. All right, so find a least common multiple of the denominators here. So between 3 and 4. All right, and then coincidentally, it's the same as the last problem, right? Between 3 and 4, we have a least common multiple of 12. All right, so let's multiply this entire equation by 12. Distribute 12 to everything. And again, if you see things that cancel out right away, you can do that. But again, I'm just going to write it out. 12 times 2 is 24x over 3 plus 1/4 x times 12 is 12 over 4x. And then 12 times x is just 12x. And 12 times 2 is 24. And now look at these fractions and see what simplifies. 24x divided by 3 is 8x. And 12 over 4x is the same as 3x. All right, and this equals 12x plus 24. Right, and then 8 plus 3 is 11x equals 12x plus 24. And then you can just subtract the 12x, cancel it out. And then we get negative x equals 24. And then we can't leave it like this. We have to get rid of that negative in front of the x, right? So let's divide both sides by -1. And then we get x equals negative 24. Again, don't just leave it as positive 24. All right. It's more than just a little sign mistake, right? These are completely different answers. All right, so we need to make sure to get rid of that negative in front of the x. The answer is x equals negative 24. All right, but essentially the same as the previous problem, right? We wanted to get rid of the fraction, so we multiplied by a common denominator. All right. All right, and now looking at something like number 15, right? So we see a whole bunch of brackets and parentheses, right? These, don't forget, guys, your order of operations, PEMDAS. Right, what's the first thing we always do is our parentheses, right? So let's look at our parentheses here, our groups, right? We have a bracket, and inside of this bracket, we have a parentheses. All right, looks like there's nothing we can do to 3 minus x already. So let's just combine everything on the inside of these brackets, right? So this negative on the outside of this little group right here, remember, this negative you can treat as a -1 and then distribute it. All right, so then we get 2x, and then distribute the -1, we get minus 3x plus x plus 5. All right, this is all still in the brackets with the 4 on the outside and then negative 7x minus 2 on the other side. All right, and now we got rid of the parentheses on the inside, right? So if you distribute the 4 right away, it's not wrong, but there's a simpler way to do it, and that's by combining all the like terms on the inside of the parentheses. All right, and I just made a little mistake right here, right? This should just be minus 3. All right, minus 3. All right, no x on that one. All right, so combining the like terms on the inside here, all right, 2x and x is going to make 3x. All right, and then negative 3 plus 5 is going to get us a plus 2. All All right, and then now we have less things to distribute. Or less things to distribute to, right? We can distribute this 4 to everything on the inside. And then we just get 12x plus 8 equals negative 7x minus 2. All right, and then you just solve as normal. All right, so then you can subtract 8 on both sides, add the 7x on both sides. So then we get 19x equals negative 10, and then divide both sides by 19, and then we get x equals negative 10 over 19. All right, last slide here, let's try some of these, right? So let's start with number 16, right? It's gonna work the same as always, right? You just wanna distribute this negative 2 to everything. So we get negative 2x minus 8 plus 3x equals x minus 8. All right, combine like terms as always, we get x minus 8 equals x minus 8. Now, if you notice from here that these are exactly the same thing, you would know that this is a special case, right? But maybe you want to keep going, right? Maybe you want to get the x's to one side and then the 8's on the other, right? But from here, maybe you see that everything cancels out. So we just get 0 equals 0, right? Is this a true statement? All right, 0 does equal 0, right? So this works. If this is the case where you have a true statement, after trying to solve it, you did everything correct, but everything cancels out and you're left with a true statement, this is all real numbers. Right, so this is one of our special cases that leaves us with an all real number solution. All right, let's try the next one. All right, so this one, let's try it the same way. All right, distribute the 3x to everything, then we get 9x minus 3 equals 9x plus 7. And then maybe again, you want to try the same thing, getting all the x's to one side, getting your constants on the other. All right, but then you end up with 0 equals 10. Now, is this a true statement? All right, absolutely not, right? 0 absolutely does not equal 10. If this is the case, where you end up with a false statement after doing everything, right? You did everything correct, distributed everything correct, moving everything to the other side, and you end up with a false statement, this is going to be a no solution. All right, so this is our other special case, right? So these are perfectly valid answers if you did all the math correct, right? So don't be scared if this happens, right? Maybe you're like, oh, where did the x's go, right? That is a perfectly normal thing to happen, right? And these are the only two possible cases where you'll see something like that happen, right? You'll get an all real number solution or a no solution, right? So if the x's cancel out, it's going to be one of these two, right? So I know some kids, right, when they see this happen, right, sometimes they say, oh, 0 is our answer, right? But no, did we clearly get that x equals 0, right? We didn't in this case. We just got 0 equals 0. Even though that's true, you can't just say that 0 is your solution, right? You have to explicitly get x equals 0 as a solution for it to count, right? So even if you get something like this, a true statement where 0 equals 0, this is still in all real numbers because you didn't get x equals 0, all right? Okay, good. So maybe you can probably tell what's going to happen with the next two, right? So on that note of getting an all real number solution, right? So let's try some of these, right? And let's see what happens, right? So as always, let's solve like normal. Distribute -6, distribute -3. All right, we should get -12x minus 6. Distribute the -3, we get -3x plus 12. All right, equals -15x plus 1. All right, and then -12x minus 3x, combined like terms is going to get you -15x. And negative 6 plus 12 is going to get you a plus 6. And on the other side, we still get a negative 15x plus 1. All right. Maybe you see what's going on here right away. All right, but let's keep going. Right, in case you don't see it yet, right? Let's keep going and see what happens here. Right, notice the 15x's all cancel out. Right, at this point, we don't even need to move the 6 over to the other side. What happens here now that the 15x's cancel it out, or the negative 15x's? We get 6 equals 1. Is this true? Again, absolutely not. This is not true, so this is another no solution. All right, so if you did everything correct, you did all your steps right, and you still get that the x's cancel out, check what kind of statement you're left with. This is a false statement, so this is a no solution. All right, and then real quick, let's try the next one. All right, so I know we kind of made a stink about the fractions, right? But this is a fairly easy one, right? This one we can just distribute the 1/2 to the 6x and the 14. All right, because then what happens here, right? We get 6x over 2 plus 14 over 2, right? These are both nice whole numbers, all right? And this equals x plus 1 plus 2 times x plus 3. All right, so then these end up with nice whole numbers, so then we get 3x plus 7. All right, so this one was fine to distribute the 1/2. Now let's distribute the 2. All right, so we get x plus 1 plus 2x plus 6. All right, and now let's combine like terms. X plus 2x is going to get us a 3x. 1 plus 6 is going to get us 7. And then look at this, right? And this time I won't even go any further, right? What do we have on the left? What do we have on the right? 3x plus 7 equals 3x plus 7, right? This is always going to be true, right? So then if this is a true statement, we immediately get an all real numbers solution, all right? So this is a perfectly valid answer, right? We saw that the left equals the right. So then we can just stop right here, right? All we have is an all real number solution, right? This is a true statement, all right? So hope this helps, right? So try to cover all the cases that you might see, right? And then the next video we'll go over the next part of this lesson, 1.2, we'll do rational expressions. All right, good.